Okay, so hormonal secretions, that is the whole function of your endocrine system, all sorts of different hormones. Just talking about aldosterone, ADH, antidiuretic, we'll talk about that one quite a bit. That's a big one. What else do I have written down? Your pancreas, corticosteroids, insulin. So all of these hormones have to be regulated. You cannot have a huge surge of insulin without having it have some type of effect on your body. So those levels have to be regulated somehow. So what happens is there's a release of hormones that come from the hypothalamus, and that hypothalamus is going to regulate a lot of the other hormones. So hypothalamus, part of your brain, controls secretions of the anterior pituitary. The pituitary is broken up into the anterior, the front, and the posterior, the back. So the hypothalamus regulates the front part of the pituitary, which is probably the more prominent, useful part of it. The nervous system is going to help. It's kind of like a helper in this situation. It's going to influence certain endocrine glands. And other glands are going to respond directly to fluid composition, so blood sugars, insulin, things like that. So there's different things that will affect different glands. So here, if I'm looking at my pituitary gland, the hypothalamus is what's going to start that. Peripheral, it's going to regulate other endocrine glands, is what peripheral means. And then these glands are going to affect the target cells. Where in the nervous system and blood levels or fluid levels, it's more of a one-shot. The nervous system controls it, the gland goes straight to where it's supposed to. Here, there's a two-step process. So it starts with your hypothalamus, then goes to an endocrine gland, which then goes to another endocrine gland. Your pituitary is called the master gland because it regulates a lot of other endocrine glands. So, negative feedback, I know we talked about that in a chapter earlier in the semester. Negative feedback is going to help to control hormone levels. If I have too much, the opposite's going to happen. Your body's going to secrete less. If I have too little, it's going to secrete more. So in a negative feedback system, your glands are sensitive to those concentrations. And then their job is to regulate it and keep it in normal levels. When the concentration reaches a certain level, it inhibits the gland from secreting more hormone until it's normal. So if I have too much sugar in my blood, my pancreas is going to produce more insulin to break down that sugar. If I have low blood sugar levels, your pancreas doesn't produce as much insulin. Unless you're diabetic and then your insulin levels are not controlled at a certain level like they're supposed to be. So here you can kind of see, here's average. Your body regulates, but it's not a straight shot, straight line. I don't have, and I'm making up a number, but I don't have 10 grams of insulin is the perfect mark. There's a range where it can fluctuate and still be considered normal. Just like your body temperature, when you exercise, your body temperature goes up. When you go outside, your body temperature goes down. It's still considered normal. It's not out of the normal range. So pituitary gland is one of the first ones that we'll talk about because it is a very large, important gland. It's not large. It's a very small gland, but it's very important in regulating many of the other ones. So it's attached to the base of the brain. It's actually hooked to a little stalk called the infundibulum, and that's where the pituitary sits. And that connects the pituitary gland to the hypothalamus. So do make sure you know hypothalamus, pituitary gland, work directly together. So anterior pituitary, the front part, the front lobe, consists of the glandular tissue, surrounds blood vessel, and then it's surrounded by collagen. So it's protected very well. The posterior part is very much different, actually. So the back lobe consists of nerve fibers, neuroglial cells, and they deal more with the nervous system. Anterior is going to deal more with the endocrine system. Posterior is going to actually deal more with the nervous system. And there's just a picture of it. So here is that stalk I was talking about. Anterior is going to be towards the front. Posterior is towards the back. It's even smaller. And then your hypothalamus sits above it. So hypothalamus controls the pituitary gland. Like I said, very closely related. Releasing or inhibiting hormones from the hypothalamus control what the pituitary gland does. So your hypothalamus can actually secrete hormones on its own, and then these hormones are carried into the bloodstream, and it's called the hypophyseal portal veins, and that's where those hormones enter the bloodstream. So this is just the first vein or bloodstream that those hormones are going to enter into. And then once they reach those specific cells, they're stimulated to release their hormone if needed, or slow down or stop that releasing if we have too much of it. The posterior pituitary stores hormones, and then it can release them in the bloodstream, but there again it's going to do that in response to your nervous system, nerve impulses, again from the hypothalamus. And that, I'm all right without looking at that one. Some of your very important hormones. First one, growth hormone. This will be one of the choices for the endocrine disorders that we do. So growth hormone stimulates body cells to grow and produce. Everybody should have growth hormone. It speeds the rate at which cells use carbohydrates and fats. It's what allows your bones to grow during puberty. It kicks in even more. So growth hormone, releasing hormone, comes from the hypothalamus. It increases the amount of growth hormone released. So the growth hormone, releasing hormone, comes from the hypothalamus. This is what's saying, hey, produce more growth hormone. So then growth hormone is released, and then eventually there's a growth hormone inhibiting hormone that's going to slow down the release. Which by the time a lot of you that are seniors, you're probably done with your growth spurt, possibly. So your growth hormone will lower quite a bit. Here, though, we've talked about genetically everyone's given, like, I can be this tall. There's no way I would have ever been able to be 6 foot tall. I don't have the genetics for it. My body's not going to produce enough growth hormone for that to happen. However, I will be the first to tell you, I did not drink very much milk growing up. I don't like milk. I like yogurt, I like cheese, but there are nutritional things that you can do that will help the growth hormone and help you grow to the height that you're supposed to get to. So there are things that you can do that will also affect that. Or drink too much pop at a young age during your growing period, and that could possibly stunt your growth. Imbalances, there is pituitary dwarfism or dwarfism. I have mentioned I have friends whose child has taken growth hormone, and they were very excited when he reached 5 foot tall, and that was something, that was a doctor's decision, things like that. Growth hormone has been abused in sports recently, but it can be prescribed for people who do have growth issues or dwarfism. Gigantism, the opposite of that, over-secretion during growing years, which is going to produce longer bones and things like that. So opposite of dwarfism. And acromegaly, over-secretion in adulthood. And this one's a little bit different. This will be on your disorder assignment, so I don't want to say too much about it. Prolactin, basically its job is to promote milk production after birth. So prolactin is not produced throughout your lifetime. Prolactin is going to be, its sole function is to produce milk for nursing. No normal role in males. So that is not something that really affects males at all. And if it does, that would be a mutation. TSH, thyroid stimulating hormone, controls the hormones that are released from your thyroid. So thyroid stimulating, it's going to affect your thyroid and what it produces. Thyrotropin releasing hormone regulates the release of TSH. So here again, this is coming from the hypothalamus. It's going to go to your thyroid, and then as blood concentration of thyroid hormones increase, your thyroxine releasing hormone is going to decrease as I have enough of my TSH. So lots of little, when we get into hormones, there's lots of abbreviations. Some of them are very similar, so make sure you know the difference. TSH is more important for our studies than TRH. Here's just a diagram again. So the hypothalamus is going to release a hormone to the pituitary gland. The pituitary gland is going to release your TSH